Hello friends, welcome back. In last lecture, we have discussed the derivation part of frequency response of 741 operational amplifier. In that, we have derived one equation, and that equation is dependent on A divided by 1 plus J F upon F naught, where A is open loop gain at 0 Hertz, and this is the function of operating frequency. Operating frequency. In this term, this is cutoff frequency. Here, this F is operating frequency, and in last lecture we have observed this graph also, which is also known as magnitude curve. At this point, the gain becomes minus 3 dB, and this is AOLF, and magnitude. On y-axis we have dB. At this point we have 1 megahertz. This is 0 Hertz, and at this point we have 5 Hertz, known as break frequency. This is magnitude plot for 741 IC op-amp. And in last lecture we have derived this equation, which also shows that the operating frequency, that is F, which is what? Which is if we apply VID, which is, let it be V in sine omega t, this omega or 2 pi f, which is the differential input voltage to this operational amplifier 741 in open loop configuration. This f is on x-axis of this graph or magnitude plot, and this f is so large. Because of this, we take logarithmic scale, and the gain, open loop gain of this 741 is 2 into 10 raised to power 5, which is AOL, and which is termed as 2 lakh times. Okay, in open loop. Now, for this graph observation, we have derived the relationship in last lecture. Now we will take the magnitude of this, we take magnitude of this equation. Let's start. AOL F in magnitude will be equal to A 1 plus J F upon F naught multiplied by complex conjugate of this denominator term on above and below F naught. Now by rearranging them we get AOL in F is by taking logarithmic on both the sides. Now it becomes in dB will equal to A times of under root 1 plus F upon F naught whole square, and taking log on both the side, this term is also multiplied by 20 log base 10. Now we rearrange it. Equal to 20 log base 10 A, and in log under root 1 upon under root will become minus 20 log base 10 under root 1 plus F upon F naught whole square. And from previous derivation we know that this F naught is equal to 1 upon 2 pi F, or you can say that 1 upon 2 pi R naught C. Okay, and this R naught and C is from the internal structure equivalent high frequency equivalent model. Here we have R naught, and from inside we have one capacitor C. This R naught and C will give you the cutoff frequency, and this cutoff frequency, this C is approximately 30 picofarad for the case of 741, and this resistance is okay. This will give you 5 Hertz, which is also known as bandwidth of open to 741 configuration of op-amp. Now in this equation we put the values, which is AOL at 0 Hertz will be 2 lakh, that means 20 log base 10, 2 into 10 is to power 5 minus 20 log base 10, and this F naught is 5, that means 1 upon F is operating frequency, and this is 5 Hertz and whole square. Okay, now if we want to calculate it, let's take calculator. 2 into 10 is to power 5, that is 2 lakh. Log times of this will be 5.301029, and multiplication with 20 will give us 106.020599 minus 20. Here we repeat this equation again, rest part of this under root 1 plus F upon 5 whole square, let it close, log base 10 under root 1 plus F upon 5 whole square. Now if we take that is operating frequency equal to 0. In this case, we put f is equal to 0 and this whole term becomes 0. Sorry, whole term become 1. That is 106.020599 minus 20 log base 10 under root 1, and this will become 0 because of f is operating frequency is 0 hertz. Okay, this is also in hertz. The hertz will cancel out and we remain with 0. 0 square is again 0. This whole factor will comes out to be under root 1 and this whole term will become 0 multiplied by 20 give you 106.020599 etc. and this is the final result of magnitude, AOL magnitude in dB. Okay, so at this point when frequency on this axis is 0 hertz, what is the value of AOL, which is equal to this 106.025025 etc. in dB. Okay, now in the second case, now we again take f is equal to 5 hertz. Using this equation, okay, this whole factor become 20 log 5.301029 minus 20 log base 10 and 1 plus 5 upon 5 hertz a whole square will give you under root 2 log base 10 20 minus this whole factor, which is 106 point, which is last calculation 2599. This is also in dB and this will also come into dB, and at this point, which is operating frequency is similar to the cutoff frequency of the system, then this whole term when we calculate comes out to be 3.010 dB, and when we calculate this factor we get 106.02 minus 3.010, and it is approximately equal to 930.2159 dB. That means at this 5 hertz operating frequency, the system frequency is also cutoff frequency because of the parameter, and this gain comes down, and at this point the gain is 103.015 dB. Okay, now by taking same equation, now we take f naught is equal to again 5 hertz, which is same, and operating frequency will take 1 megahertz. Then this factor is 106.02599 minus 20 log base 10 under root 1 plus 1 mega means 10 raised to power 6 hertz divided by 5 hertz, hertz cancel out, and whole square. When we calculate this factor, let us calculate 1 into 10 raised to power 6 divided by 5 and square of this plus 1 and root of this and multiply by 20 . It is approximately equal to 106.020599, which is the same as this factor. And when we subtract it, we get 0 dB, because this is also in dB, this is also in dB. That means at 1 megahertz, your gain, your strength or your system gain will become 0 dB at this frequency, and this frequency is also known as unity gain frequency, and also it is also known as crossover frequency, because after this 1 megahertz, if we put 10 megahertz in this place and then we calculate, now this factor will be large as compared to this, and we get minus term in dB, x dB. Okay, this minus will be reflecting in the dB. That means now if this frequency on x-axis is again changes, then now the gain or the system gain is crossover, and that crossover point is of 0 dB. Okay, that's why this point is also known as crossover frequency. Right. And another name is also given to this point is unity gain bandwidth product. This is only for single break frequency type system for 741, because 741 is having only one break frequency. Break frequency means at this, after this point, the system gain fall down or roll off by 20 dB per decay. Okay, and minus, you can say that. Similarly, if we are dealing with phase, we use this equation and try to find out this phi, which comes out to be minus tan inverse f upon f naught. Okay, is again your operating frequency, and this f naught is 5 Hz fixed. Now we take 3 points or rolling 3 points for your reference. If we take 0 Hz, 5 Hz and 1 Hz and putting all these things in this equation, minus tan 0, which is our operating frequency, at this moment, 5s, this whole becomes 0,